And so we wanted to carry on this theme of developing these, taking metrics that have been used in other areas and applying them to us. So a lot of people use these Poincare plots, and I'm sure I'm pronouncing them wrong. I'm not French. So we'll deal with what we have. But what they do a lot in heart rate is they look at this beat to beat interval dynamics. And what's great about these dynamics is, in healthy individuals, there's this kind of really tight oval pattern in healthy individuals. So you take your heartbeat, current one versus the other one, and they're going to have this kind of oval pattern. However, what we started to notice is that, or they started to notice, is that when you have a heart ailment, that this pattern falls apart. And what we like about these metrics is I always call them the eye test. And what I like about this is that somebody who doesn't know anything, I don't know anything about heart rate dynamics, I can very quickly look at these patterns and say, there's something wrong here. And so that was kind of the biggest impetus for using these. And one of the things we also liked about this is we want our metrics to have some meaning. So the previous one talked about motor control. And so what we want to see was, well, if we use this heart rate dynamics and these Poincare plots, what are they going to do? And so we have SD1 and SD2, and they represent the kind of the variance and variability along the short and long axis. And so we know that SD1 was kind of telling us there was an issue in the short-term variability, and SD2 was saying there's an issue in the long-term variability. And what this translated to for us is the fact that we're going to start developing some rehabilitation protocols. And we want to say, if we have see these adaptive changes, are they only storing these short-term, or are they storing these long-term? So that was kind of where we came up with this. So we use these. And again, fortunate enough, we had finally got some ACL people in the lab. And we saw that if we we did this Poincare plots on these individuals, and instead of using heart rate, we used stride time. And we saw that even in the non-reconstructed limb that's often affected, you can see that it had more of that oval pattern. However, when we looked at the reconstructed limb, very quickly we knew that there was something wrong with these individuals' gait and did not pass the eye test. So it was really great to see. Again, these metrics are sensitive, not that this person was injured. And what was concerning about this is during normal walking, and this person, I think, was about 2 or 3 years out from ACL reconstruction and rehabilitation. So these patterns actually persist for a while.
Yeah, I really like this work, and especially going back to the previous slide where you talked about how you're using metrics that were established for heart rate variability, and how that inspired your own work. I think, we've hung out at EMBC before, and I think that this is one of the things that I think early career data scientists can really get a handle on, where I think everyone should do this, where even if a piece of work does not directly apply to what you're doing, like it doesn't need to be the exact same application, the exact same models to apply to what you're doing. You can get inspiration from anywhere. And I think that I've gotten inspiration from a lot of biomechanical, some physical work, some work on the astrophysics and identifying new exoplanets. And I didn't use their methods, and clearly I wasn't even using their the same type of data, but still the actual motivation and the dynamic that I was trying to capture, it wasn't too hard to connect the dots. Like, oh yeah, I can do this from my current method, capture this new dynamic, have a new metric. And so I really appreciate you doing that. And as you just said, at EMBC, where we both, I guess, used to attend, just one of the main values of going to those presentations is you just go, you get ideas, you write them down, and you bring them back and just see what you can do. And I wish more data scientists would be open-minded enough to do that.
Yeah, no, 100%. That, and like you said, it's a purpose of going to those conferences and really gaining new ideas. So no, that's great. And so, yeah, so that was kind of the first study. So that's what we did, is we just started to figure out, can we define new regions and new regimes of healthy motor control, so that now when we start to do our rehabilitation protocols, we can start to figure out, quantify whether or not we're actually getting people back to a